Hello everyone. So the problem which we will be solving now is number of perfect pairs. So let's quickly discuss the problem description. So it says that you are given an integer array nums. A pair of indices I, j is called perfect if the following conditions are satisfied. So what are the conditions? There are three conditions that we need to take care of. The first one is I should be less than j. The second one is a is equal to nums of I, b equal to nums of j. Then minimum of a modulo of a minus b, or abstract value of a minus b, uh, comma abstract value of a plus b should be less than equal to minimum of abstract value of a comma abstract value of b, right? And maximum of this function is also given to us, right? We need to return the number of distinct pairs, right? Perfect pairs. So these are the three conditions that you need to take care of, and if these three conditions are there with you, then you can call it a pair of integers perfect. So you need to return distinct perfect pair, right? uh, Before jumping to the solution, let me let's discuss the brute approach, right? What is the brute force approach? Brute force approach would be to traverse on all the indices, right? Start from for I equal to 0 to n, right? For loop, right? And again go inside the another loop for j equal to I plus 1, right, till n. And you can check for every indices that it is valid or not, right? So if you do this will take a big O of n square, right? And if you see the time constraints given to the problem statement, it is nums dot length can be 10 to the power 5, which will give you a TLE, right? So what solution will work for us? It will be big O of n log n at most you can go, right? Or if you can do it in big O of n, that's more good for us, but we can go till big O of n log n, right? Okay, so how will we proceed to the solution, right? Okay, before jumping into the solution, let me give you some eye-opener things, right? What are the function given to us, right? Let me write those function to you, right? And when I will explain, first let me explain a part, right? The first point which I want to make to you is this one is, let's say, if we sort the array, there won't be any difference. But just now we saw a condition that I should be less than j, right? But I am saying that sorting won't cause any issue, right? This is, let's call this point number 2 for me, right? And the first point which I will prove to you, I am not just saying anything in my like hawa mein baatein nahi kar raha, I will prove these things to you, right? And the second thing is abstract, do abstract of all the nums, right? So let us quickly look the first proof, right? That if we do abstract value of the nums, still the values of the array or the answer won't be changed, right? Okay, so how I'm saying this, right? So for all our test cases, for all my proofs, right, I will take this value. I will take a value 5 comma minus array. I will take 5 comma minus 9, right? Okay, so you can take any other value, you can try on all other values of your wish. I will try to prove using these two values only, right? Okay, so my first debate to you was, if you do abstract value also, no, it will be same as it is, right? Okay, before doing that, let me first do check this is valid or not, right? So what will be the answer? It will be minimum of modulo of a minus b, or abstract of a minus b, that is 5 minus minus 9, right? Let us call this I, let us call this j, right? So 5 minus minus 9, which would be 5 plus 9, which is 14, right? Comma 5 minus 9, right? A plus b, which is 5 plus minus 9, which is minus 4, right? Okay, this should be less than equal to minimum of abstract of 5 comma abstract of 9, which will be 5. So I'm directly writing a 5 over there. No need to, I don't think that I need to explain this thing again to you, right? And if you do a minimum of these two, this will be a 14, this will be a 4, and minimum of these two, right? So this will give me a value of 4, right? And this makes the first condition true for this value, right? Okay, let's look at the second equation. Second equation says that abstract and max value, right? Max is 14, right? So max of 14 comma 4 should be greater than equal to max of 5 comma 9, that is 9, right? So 14 is definitely greater than 9. So both conditions are holding true, therefore this is a valid pair, right? Okay, so now I'm saying the point which I made is do abstract, right? What does this mean? This will make my array look like, or the pairs or the values which we are having look like 5 comma 9, right? Okay, so if I have a pair 5 comma 9, now let's again look at these two equations, right? uh, while I'm pasting it, if you like this content of me, if you understand it, please do like and share and subscribe as well, right? So my point was to make this array as 5 comma 9, right? Now let's look at it, right? 5 comma minus 9, which will be 5 minus 9, which will be minus 4, right? Comma 5 plus 9, which will be 14, right? Less than equal to minimum of 5 comma 9, which will be 5, right? So it will ultimately give me 4 less than equal to 5, right? And this condition holds true. Okay, max of these two value, it will be 14, max this side, and that side will be 9, right? So 14 is also greater than equal to 9, and second condition also holds true. That means I have proven to you that if you do a abstract value as well, the values or the answer won't change for you, right? And let me show you one more interesting thing, right? If you see this if you see this equation, right, let me take another color, right? If you look at this equation, right, and if you look at this equation, this might not be that exact, but let's look at this equation, right? And if you look at this equation, both equations are same, right? These are similar, right? So what can we understand from this place is, if you do abstract of a minus b, or abstract of a plus b, right, that won't vary to you, right? Means if a number is 5 comma minus 9, or the number is 9, or the number is 5 comma only a 9, right, these value will ultimately give you same result, right? So that was the first point which I wanted to make to you, right? So that, what does this mean? That if you want to solve a problem, do abstract value, right? Bring them all down to the positive integers, right? So I hope the first point made sense to you, right? If you look at the equation also now, it is doing nothing but once a number is added and once a number is subtracted, right, means once it is a minus b and once it's plus b, right? So if even if you change the order, right, even if you change the order, that won't be causing any difference to you, right? The ultimate function will be same, right? Because see, at the end you are doing abstract, so both numbers will be positive, and once you are doing a minus b, right, let's say the number was initially minus 9, right? So once you are doing minus 9, once you are doing plus 9, right, even if you have changed this number to 9, right, now still you would be doing a minus 9 and a plus 9, right? Because minus b is always there, right? So this was the first point which I wanted to make to you, and I think and I hope that that point is clear to you, right? Now the second part was, we can sort the array. Now this looks a bit little tricky, right? Because if we sort the array, right, how will this condition be satisfied, right? Okay, again let me make a proof to you, right? Why not just look at some examples, and then let's judge that is this thing real or not, right? I will take the same example, sir. 5 comma minus 9, right? So first approach, the first thing which I said to you, you can make this as 5 comma 9. Okay, applicable, let's apply it, right? Now let's look at it, right? So I'm saying you can sort it and it will not make any difference, right? Means even if it's written 5 comma 9, right, or let's say it was written 9 comma 5, it won't be any means the answer won't differ, right? So instead of taking 5 comma 9, let me show you with 9 comma 5 so that you can trust me that 5 comma 9 when sorted, this value when sorted, then also the answer won't differ, right? So what will I am taking, my array is now 9 comma 5, right? Now my this value is I and this value is currently j, right? Okay, so minimum of a minus b, right? What will be that value? Minimum of 9 minus 5, which is 4, comma 9 plus 4, 14, right? Less than equal to minimum of these two values, which will be 5, right? So 4 is less than equal to 5. First equation is true, sir. Let's move on to the next equation, sir. Next equation says that max of a minus b, so simply max of 4 comma 14, right? I have calculated that value already, this value, right? This should be less than equal to 9, right? And sorry, this should be greater than equal to 9, my bad. And yes sir, it is also true, 14 is greater than equal to 9. So again, this shows that this is a valid pair, and we already knew that it is a valid pair, right? Because we have shown in abstract form that okay, values are same. Now my point was, if it was 9 comma 5, it can also be written as 5 comma 9. Now how? Let's look at it, right? So let me paste that thing again, right? Now a and b values have changed, right? Now a have become 5, 9, right? So minimum of 5 minus 9, which will be minus 4, right, comma 14. So till now we have understood, I think, that these numbers aren't changing, right? 4 comma 14, right, is always constant, right? Even if we did abstract, we did sort, right? Let's not break the flow, let me complete it, right? Sorry for that. This should be 5, right? And similarly max of this value, abstract value, should be greater than equal to 9. So the equations are always the same, right? No matter what you do, if you are doing these two equations simultaneously, na, you will get every value as same, right? And I have showed you also, right? The first one, abstract one, I showed you, na. Let's say b was minus 9, right? So once you did a minus b and once you did a plus b, right, for minus 9, right? So it became plus 9 and once it became minus 9, right sir? And at the next point, if I said do a plus 9 instead, then the equation would have become minus 9 and plus 9. So see, the values are just interchanging, right? So it won't be any difference to do a abstract value of that one, right? Okay, so and I have showed that sorting also doesn't matter, because if you do a minus b, right, if these values are swapped, right, then also the answer will be same, right? I have shown this one to you, right, with this example. So my both points are clear to you, right? Now if my both points are clear to you, right, we are almost close to the solution. So first what I said was sort the array, right? Sorry, so first was do abstract value and then sort the array, right? Now these two conditions when holded, right, these two conditions when I have implemented, now it's time to calculate the answer, right? So how will I calculate the answer, right? Let's take a number 3, right? After doing a app's value, 3 is standing at some place, right? Now we are jumping to the solution directly, right? So let's say add a 3, add a 4, add a 6, add a 7, right? So if you calculate value for 3 comma 4, right, if the values are 3 and 4, right, you will get this as a valid pair, right? Now why will you get it as a valid pair, right? So 3 minus 4 will give you on the left hand side, right? Let me again paste that equation, right? Okay, so this value, right, on the left hand side, the minimum will be 3 minus 4, that will give me a minus 1, right? And on the right hand side it will be 3, right? So this is valid, right? And maximum of 3 plus 4 will be maximum, right, which is greater than equal to our absolute value of this, right. Now if you closely look into this, right, and if I tell you do for 3 comma 7, right, now look at this, now look at something special, right. So 3 comma 4 was special, right, or let's say perfect, but 3 comma 7 is not special. Why? Let me show that to you, right. So for 3 comma 7, when you find the minimum value becomes minus 4, right, because two positive number, right, the minimum that you can get is by subtracting them, right. Two positive numbers, if you do want a minimum out of them, then definitely you need to subtract them, right. By adding them you won't get a bigger, you will get a bigger number, right. So to get a minimum you will subtract them, and if you subtract them you get a value minus 4, right. And when you do a absolute value of that, that will be definitely greater than minimum of these two, right. So what can you observe from this? What we can observe is, for 3, let's say the smaller number, the largest which you can take is 6. Why? Because 6 minus 3 will be 3, right, and anything bigger than 3 will violate my first equation's this side of condition, right, because minimum of, let's say you took 9, right, so 9 minus 6 will be the minimum that you can have from 9 and 3 pair, right, that will be 6, right. So 6 is definitely not, it is false for 3, right, because minimum of these two values 9 and 3 will be 3, right. So this condition will fail. So what you can understand is, for let's say 3 you can take 4, you can have 5, you can have 6, but not 7, right. Similarly for 4 you can have 5, 6, 7, 8, but after you do 8 minus 4 you will get 4, right. But after that if you do 9 minus 4 you will get the minimum value as 5, which violates your condition. So you can at most have a value, let's say value as x, whichever value you are finding, right. So at most you can go from val to val into 2, right. Okay, so for any value I can go from up till val into 2, right. This is my statement to you, right. Are you accepting this thing? I hope so you are accepting after listening to all my proofs which I have given to you, right. So if I am saying this, that you can go till val into 2, will you again traverse from this number to all the integers and find that is this valid or not, right. It will ultimately give you a big of n square solution, right. So what can we do rather? See, when I said you can sort the array, that might have clicked your mind that okay, we can use binary search if you want to find the value which is greater than or equal to val, right. Means I can go from val to 2 times val, right. Why not? Let's find the index where we up till which we can go. So here comes the concept of upper bound, right. So I hope you know what upper bound is. Even if you don't know, let me give you a brief intro to it. So upper bound is, let's say you have any value val, so it will find you the index, right. It will find you an index where the val, or let's say where the integer, right. Let me do this. Yes, where nums of I is strictly greater than val, right. So if I get an index, let's say 3, and I had a 4, I had a 9, let's say, right. So if I am calculating for 3, which value I can go? I can go till 6. So if you do a upper bound to this, this will throw you to 9, right. And if you go to 9, you definitely know that this is the index up till which we can go, right. So what I'm trying to convey is, you can go till 4, right, not 9, but you can definitely go till 4, right, because 3 comma 4 will be in my range, right. 3 comma 4 is a valid pair for me. I hope this thing doesn't confuse you. Let me take a small one more thing. Let's take 3, 4, 5 and then 11, right. So if you do a upper bound for 3, it will be 6 value is what you want. So if it upper bound searches till this index, right. Now you definitely know you can't go till 11, but you can come beyond, means one index behind 11, right. So this index is a valid one, right, and that's what you can find easily using upper bound in view of log n. right? That's it. Now if you look at my code, it is pretty simple. Whatever I have told you till now is what I have coded up, right? So if you look at it, these are the constraints. I have first did an abstract value, then I have sorted the array, then I am doing num equal to abstract of 2 into nums. Still I am again doing abs. I don't know why I did this, but yeah, 2 into nums. Even if you remove this, there won't be any problem. You can try it off, right? So 2 into nums of 5, and you are finding the index, right? Upper bound, using upper bound, right? And you are doing a -1, right? Why -1? Because let's say you reached 11, will be your, this will be your index which you will get in your upper bound, and you can traverse -1, right? You can't, means see, upper bound मेरे को देता क्या है? Upper bound gives me a value which is greater than x, right? So वो मेरे को 11 पे थ्रो करेगा, राइट? बट मैं 11 से जस्ट पीछे तो ज़रूर जा सकता हूँ, राइट? 11 से जस्ट पीछे मेरे आरे में क्या है? 5 है, और मेरा अपर बाउंड मेरे को ये कभी तो नहीं देगा, मेरे को पता है, राइट? बिकॉज 6 इज़ डेफिनेटली ग्रेटर देन 5, राइट? तो इसलिए अपर बाउंड में ये वैल्यू तो कभी नहीं आएगा, राइट? इसलिए मैं -1 कर सकता हूँ उस पर, राइट? सो that's why I have done a -1, right? And if index is greater than I, simply do answer plus equal to index minus I, right? Let's say यही वाला टेस्ट केस देख लेते हैं, राइट? 0 1 2 3, राइट? तो मेरा इंडेक्स मेरे को कहाँ पे करेगा? यहाँ पे करेगा। मैंने -1 किया, इंडेक्स यहाँ पे पॉइंट करेगा, राइट? और मेरा आई इस पॉइंट पे। तो कितने वैलिड पेयर हैं? 3,4 एक वैलिड पेयर है सर, 3,5 एक वैलिड पेयर है, राइट? और कोई वैलिड पेयर है? नहीं। तो क्या हुआ? इंडेक्स माइनस आई, राइट? दैट्स वाई इंडेक्स माइनस आई, एंड एट द एंड वी आर रिटर्निंग दिस, राइट? So that is it for the code, right? If you look at the time complexity of it, it is big O of n log n, because we are sorting and using a binary search for it, right? So I hope you have understood all my points. If yes, please do like my video, and please subscribe my channel. Motivates me a lot. Thank you for watching, and if you have any more doubts, you can definitely ask in comments. Thanks for watching.